Our new topic that we're going to be tackling on Wednesday is function notation. So, most of the time, a lot of the time, we use y and x, right? Our input and our output, as we've been discussing with domain and range. These are not the only possible things we could use, right? Sometimes, as we saw with the handshake problem, we might have h is equal to n minus 1 divided by 2, right? So this is not function notation. This is handy. This is the way we would normally think of it. This is just an equation relating to ideas. And if we have the definitions, h is equal to handshakes, and n is equal to the number of people in a group, then we understand what this equation means. Now, function notation takes this equation and makes it slightly more complicated, but a little more open and universal to be used in other ways. So function notation would take something like y is equal to 3x, which we could represent in different ways because that's my jam, right? We could represent that as a table. 3 times 0 is 0, 1 times 3 is 0, 2 times is 3. Ignore my words and just look at what I'm writing because that's right. So we could do a table, right? We could write this in words. The output is the input. Times 3 or tripled, right? We could also make a cute graph of this, which is where we're going to be heading when we start talking about linear functions, right? But we'd have this lovely graph of all these different values. There's a bunch of different ways to represent these. But what we care about for tomorrow's class is not all these different representations, but a specific way of making a notation for this exact same thing that we were dealing with here, the y is equal to 3x. So our function notation version of this, instead of using y, we're going to use f of x. That's how that is said. So I'll rewrite that for you. This is f of x. What this means it is not, and this is a huge note, not f times x. That's how a lot of students will see this. What this actually means, f of x, means that our f, our output, depends on x. So this is more useful in our handshake problem, right? If we have something like h of n is equal to n minus 1 over 2, what we're saying, that n looks like an h, is that the number of handshakes required is dependent on how many people are in the group. If there's 5 people in the group, it's going to change, right? So what do you need to know about this notation, besides that it's not multiplication? You need to know how to use this notation. So let's just keep playing with f of x is equal to 3x. We'll bring that back down. This allows us as mathematicians to give some shorthand. Instead of writing what is y if x is equal to 3, right? That's a lot of words if we had this as y is equal to 3x. What is y if x equals 2? Like, that's a lot of words. And again, us mathematicians are lazy. We can write all of that very concisely using the function notation. We just replace the x with a 2. So what is f of 2? Well, f is essentially the rule. So the rule says that whatever the heck I put in, whatever my input is, I'm going to triple that input, right? What we said in words. So if I'm inputting 2, well, I'm still going to write my same rule. I'm still going to triple it. 3 times 2. So now I have shorthand. Instead of saying what is y, I can just use this shorthand, f with whatever the heck I want to actually evaluate in parentheses. So I'm going to give you guys an example to try on your own because I think you are pretty good at evaluating. I haven't created those little quizzes yet, but I feel like we're good. So I'm going to give us a couple of different functions, the different rules that we could use. I'm going to call f of x. Let's just keep it still 3x. Keep it simple. Let's make g of t. It really doesn't matter what the heck I name this inside variable, as long as whatever the heck the rule is that follows uses that same variable. So let's just make this t squared. And heck, let's do another one, h of, and then you guys will learn this is my favorite variable of all, just to show you how much the variable names do not matter. H of cat face is equal to cat face plus 1. So in words, what do our three different functions do? Well, f of x triples, right? The f function triples whatever we put in. The g function squares, right? It takes whatever the heck we put in and it squares it. And the h function adds 1. So that's the, in words, what our different functions do. Again, it doesn't matter what the heck I name or put inside of the parentheses as long as it matches here. And then we got it. So I'm going to give you a couple of different things to test out. So let's find f of -4. Let's find g of -4. And let's find h of -4. So I want you to take a moment, pause the video, figure out each of those different values, and make sure you feel comfortable with the function notation. All right, so coming back, remember, this is just giving us a rule. Whatever is inside the parentheses is going to replace the x. So this one is going to multiply by 3, this one is going to square, and this one is going to add 1 to whatever our input was, which was always -4. So 3 times -4, -4 squared, and -4 plus 1. So our three different values are -12, 16, and -3. Now there is one way I can make this slightly more difficult, and that is to, instead of just having you put in a value, a number, to instead have you put in another expression. So what would that look like? Well, let's do f of k plus 2. The rule is still the same. It doesn't matter that what's inside of these parentheses, the f what I'm evaluating with my function, is more than one term. I'm just going to replace the x with whatever was inside of the parentheses. I'm still going to triple whatever my input was. The one thing here is that you do want to make sure that you use parentheses, because if I don't use parentheses, I may not be tripling the whole value, right? I want to triple all of k plus 2. So if we wanted to, we could simplify this up by distributing, and then we have our final answer. And this is as good as it gets. If I have a variable in my input, I'm going to have a variable in my output as well. The only time I'll have a nice pretty number is if I plugged in a nice pretty number. So that's function notation. We'll definitely have one of these questions on the quiz tomorrow, along with questions on, again, function versus relation and domain and range, which we saw today.